15, the one I did right before this, if you're watching these in order with Miguel and the Statue of Liberty, was number 14. But you look at your book, you could figure that out. So number 15, a flagpole, the world's tallest unsupported flagpole. That's reassuring. It's 282 feet tall, and the shortest shadow cast by the pole is 137 feet long. To the nearest degree, what is the angle of elevation of the sun when the shortest shadow is cast? So we're relating the flagpole. So this is the flagpole. This unsupported flagpole is 282 feet. It casts a shadow of 137 feet. It's a little bit smaller, so it's somewhat drawn to scale. And it wants to know what is the angle of elevation of the sun. So here's the sun, because if you have a sun, then your shadow is going to go this way. It wants to know the angle of elevation. So the angle of elevation would have to be here because we have our horizontal line and it's going upward. It could not be here for a couple of reasons. One, you don't have a horizontal line, and two, it's going down. So we want elevation means up. So it's asking for the angle of elevation of the sun. So horizontal line going up to the sun. So I put theta here, you can put x, I don't care. Just know that it's an unknown. So we have 137 feet for the shadow. The pole is 282 feet. So we have opposite and adjacent. So TOA. So opposite, adjacent. So we have tangent of our angle is going to be opposite over adjacent. So remember, we're trying to figure out an angle. We do the inverse tan of 282 over 137. So x is going to equal 64.0887. It says to round to the nearest degree, so this would be 64 degrees. For number 16, the Americans with Disability Act states that a wheelchair ramp can have a slope no greater than 1/12, or 1/12. So keep in mind, slope, rise over run. Find the angle of elevation of a ramp with this slope. Round your answer to the nearest tenth. So keep in mind if you're in a wheelchair and you're going up a ramp, you don't want it to be too steep, but they're telling you that the slope is 1/12. So think of rise over run. And the reason I knew to think that is because it said slope. So when we have a slope, it's rise over our run. It's asking for the angle of elevation. So you are looking for a horizontal line and a line that's going up. So horizontal line going up. So it's asking for this degree right here. So we're going to figure out, we're going to use sine, cosine, or tangent. So we have opposite and adjacent. So tangent of our angle equals opposite over adjacent. And then again, we're trying to find our angle, so that's when we know to use the inverse tan. If you're trying to figure out a side, then you just use the regular tangent function. going to equal 4.763. It does say round to the nearest tenth, so that's 4.8 degrees. And then 17, two office buildings are 51 meters apart. The height of the taller building is 207 meters. Oh, so the taller one is here, that's 207. The angle of depression from the top of the taller building to the top of the shorter building is 15 degrees. Find the height of the shorter building to the nearest meter. So they have the angle of depression, you have your horizontal line, and then it's going downward. That's 15 degrees. I'm going to redraw what they have here. So this is 51 meters. So if 15 degrees is here, it also is there. Didn't do a good job redrawing that, so I'm going to try that again. So 15 degrees is here. It's also going to be here because if you have two horizontal lines, they're going to be parallel. And then you know that the length from here to here is 51 meters. We need to figure out the length here because if we know that the taller building is 207 meters, if we can figure out this little chunk here, we can just subtract that from the 207 and that will give us the smaller building. So we have opposite and adjacent. So we're going to do tangent of 15 equals opposite over adjacent. And then we cross multiply. So x is going to equal 51 times the tan of 15. X is to round to the nearest meter, so I have 13.6654, so the nearest meter would be 14. So that means this is 14 meters. We're not done here because it's asking for the height of the shorter building. So if we know the bigger building is 207, the little gap in between the shorter and the tallest is 14 meters. So we take the 207 and subtract the 14. Sorry, my pen is being goofy. So 207 minus the 14, so 193 meters. So you can go ahead and do the practice 8-5. Remember to draw pictures. On your quiz or test, that will be required for you to draw a picture. So get used to drawing a picture and labeling the correct sides. This is number 14, I believe. So Miguel looks out from the crown of the Statue of Liberty, approximately 250 feet above ground. He sights a ship coming into New York Harbor and measures the angle of depression as 18 degrees. Find the distance from the base of the statue to the ship to the nearest foot. So, Statue of Liberty, and the ground, I have to make it more straight. So, Miguel is 250 feet from the ground. He sights a ship. So this is the boat out here. So this is where issues happen because we think angle of depression is going down, so this is 18 degrees. And that's not the case because I do not have a horizontal line. So I need a horizontal line and then the angle of depression. So 18 degrees would go there. So I'm trying to emphasize to you, you need a horizontal line and then going down. So you can either move over the 250 over here, or because you have two horizontal lines, those are parallel, then you know if 18 degrees is up here, because of alternate interior angles, 18 degrees is there as well. Well, which really is here. So it's asking you for the distance from the base of the statue to the boat. So I'm going to put X there. So redrawing that. This is 18 degrees. This is 250 feet. And I'm going to try to find this length here. So I have opposite and adjacent. So I know I'm going to use tangent of 18 because of SOHCAHTOA. So that's opposite over adjacent. So we're going to cross multiply and get 250 equals the tan of 18 times x, and then divide by the tan of 18. So x is going to equal 769.42, round to the nearest foot, so that's going to be 769 feet. Now, kind of a shortcut for you, if you see it, notice if we divide by x, we have to do more. Like usually when we cross multiply, we can just multiply, but here we had divide by the tan of 18. If you're dividing by the x, you can move these around and flip-flop these. So you would get x over 1 equals 250 over tan of 18, which will get you to the same spot we were just at right here. So if you're dividing by x, you can flip-flop the numerator and denominator around, and then that will tell you what you're going to be dividing. Otherwise, you can just cross-multiply and then solve for x, but that's just a shortcut for you as well. So the homework you're doing in your book, so you have 9 through 17, and then you have a worksheet, practice 8-5. So the answer key is online for that, but again, if you just copy down the answers, that's not going to help you when you get to your quiz coming up or your test. So make sure that you're motivated to show the work, do the work, and then ask questions if you have any. So for number 9, find the value of x, round the lengths to the nearest tenth of a unit. So we need to figure out if we're going to use sine, cosine, or tangent. So we have opposite and hypotenuse. We're going to have sine of your angle equals opposite over hypotenuse. And nothing's different like we've been doing, cross multiply and then solve for your x. For this one we have opposite and adjacent. So this we're going to use tan of our angle equals 203 or 203 over x. So keep in mind if you cross multiply in this one, you're going to x times tan of 22 equals 203 and then divide by tan of 22. And that will give you your x value. But the one that I want to do to show you a picture is number 11. A meteorologist measures the angle of elevation of a weather balloon as 41 degrees. A radio signal from the balloon indicates that it is 1,503 meters from his location. To the nearest meter, how high above the ground is the balloon? So we're going to have a ground because we want to know how high the balloon is from the ground. So it's not, a weather balloon does not look like a regular balloon, but I'm going to draw it as it is. That's my balloon. Perfect. It's like an octopus, but we'll just go with it. So a meteorologist measures the angle of elevation. So we're going up. So that's 41 degrees. A radio signal of the balloon indicates that it is 1,503 feet from his location. So we're going to have an angle of elevation. This is the view of the person, meteorologist. I know that this is the angle of elevation because I have a horizontal line and it's going up, so we know that is 41 degrees. The radio signal from the balloon indicates that it is 1,503 from his location. So from the balloon to his location is 1,503 meters from the balloon to his location. It wants to know how high above the ground is the balloon. It wants to know x. So we have opposite in hypotenuse. So we're going to use sine. So sine of my angle is going to equal opposite over hypotenuse. We can cross multiply. So sine of 41 times 1,503 is 986.0567. It doesn't say what to round it to for this one, so I'm going to round to the nearest hundredth. Because if it doesn't tell you what to round it to, round to the nearest hundredth. Usually if it's degrees, you're going to round to the nearest degree. Actually, I'm going to use the directions for this one up here. Round to the nearest tenth of a unit. So that being said, this should be x to equal 986.1 meters.